Hey, good morning, physics students. Welcome to AP2. We are going to be going over thermodynamics. This is going to be our intro into thermodynamics. We're going to discuss temperature, heat, what's the difference between those, and everything else. So we're going to go to the first screen. Okay, so you can hear this concept a lot. It's called thermal equilibrium. And here's when thermal equilibrium happens, is you have no net exchange of heat between two objects. Here's what that means. Those objects are going to be at the same temperature and there's no net flow of heat, but that doesn't mean there's no flow of heat between them at all. It means if one object loses 5 joules of heat, the other object loses 5 joules of heat back to the first one. So temperature, again, is the indicator that thermal equilibrium is occurring. So here's some definitions and just things that you need to have. First little question I put up there, when you touch a piece of metal and a piece of wood in front of you, which one would feel warmer and why? So take a second, kind of think about that, and we'll discuss it. For most people, the one that will feel warmer usually is the wood. The metal is usually going to feel cooler to the touch, and here's the reason why. They're both at the same temperature. Because they're in the same room and they've been there for a while. The metal, however, is a better conductor of heat. So the reason why it's feeling cooler to you is because it's pulling heat out of your body and into it. The wood is not as good of a conductor, which means it's not pulling as much heat out of you as fast as the metal is. Two definitions that are just important to understand the difference between. Temperature is the measure of the average kinetic energy contained in an object. And heat is basically a form of energy, and heat can also be defined as the total energy that an object has. So, for example, a pool that's, let's say, at 70 degrees versus a cup of water that's at 100 degrees, it's boiling. The cup of water is at a higher temperature because the number is higher. However, the pool has more heat total because there's more water inside the pool. So heat also accounts for the total amount of energy inside of an object. Okay, 3 common temperature scales that we're going to use throughout, and that you've probably seen 2 of them for sure. Fahrenheit and Celsius, you've probably heard of. Kelvin, you may not have, and Kelvin's going to be the one we actually use quite a bit in here. Here's a couple of important notes about Kelvin. It has no negative temperatures. The lowest temperature in Kelvin, if you notice on the chart there, is 0. That's called absolute zero, which means that's when all of the atoms and all of the molecules stop vibrating down to the subatomic level. That's at negative 273 degrees Celsius and about negative 460 degrees Fahrenheit. So extremely low temperature. We've actually not been able to get anything down to absolute zero, and we will talk about why here in a few minutes. So temperature conversions, a couple things you're going to be wanting able to do. I've got those there for you. To go from Fahrenheit to Celsius, that's the top equation right there. And then to go from Celsius over to Fahrenheit is this bottom equation. And then one other equation that we have is how to convert from Celsius over to Kelvin. You add 273.15. And then to go the other route, you would just simply subtract 273.15. Heat. So a couple concepts about heat that are important. One thing that you do, if you took a cup of hot water and you poured it into a cup of cold water, you would notice that some of the water would cool down and some of the water would warm up. The water that was hot initially would lose energy. The water that was cooler would gain energy. As they get to thermal equilibrium, that net exchange of energy goes to zero. So what you have is energy flows from higher temperature to lower temperature, and the flow of energy is often called heat. The symbol that you're going to see in a lot of equations for heat is Q. One of the key things to remember is there's a difference between temperature and heat. Temperature is your average kinetic energy, and heat is the measure of either total energy or the transfer of energy between objects. Okay, unit for heat, because heat's a unit of energy, the unit for heat is going to be joule, and the symbol for that is going to be J. Okay, the first law we're going to call is actually called the 0th law of thermodynamics. And here's the idea with that is if two objects are in equilibrium with a third object, they are also in equilibrium with each other. So here's the idea. let's say T1 is in equilibrium with T3, and then T2 is in equilibrium with T3. That means T1 and T2 are in equilibrium with each other, which means essentially they're all at the same temperature. So here's a practice question. Take a minute, kind of read through that, and we're going to talk through that here in just a second. So pause the video here and we'll come back and talk about that. All right, now that you have unpaused, we want to know which of the following is true when object A and B reach thermal equilibrium with object C. So which one of those is true? So we notice in here they all have different temperatures. A is the warmest, has the highest temperature, then B, then C. So they want to know what happens when A and B all get to thermal equilibrium. They all three will have the same temperature. That just goes back to the zeroth law. If two things are in equilibrium, if A is in equilibrium with C and B is in equilibrium with C, they're also in equilibrium with each other. So A, B, and C are all in equilibrium with each other. All right, heat transfer. Three main types, excuse me, of heat temperature that we're going to talk about: conduction, convection, and radiation. So conduction is probably the one you've heard the most and most familiar with. This is when objects are touching each other, and you have collisions on the molecular level that happen in the object. This usually happens in solids. So this is kind of one that you may be really familiar with. Convection. This is the process where heat is transferred between gases or liquids. What happens is warm molecules will rise because they have more energy, and then the cooler molecules will tend to fall, and then they switch places as they begin to get to thermal equilibrium. Radiation is another type of energy transfer. The important thing about this does not require a medium to transfer. So what that means is this type of energy can pass through a vacuum. This is how we get the energy from the sun to the earth. It's all through radiation. A couple examples where you may have experienced this: if you stand by a fire, you're going to feel warm, or if you've ever gotten a sunburn. Those are heat transfers through radiation, and they're through what's called an electromagnetic wave. That is a long term for a light wave, and all of those things listed there are different types of light waves. And that is where we will stop for today. Y'all, please make sure and check in on Canvas and have a good rest of the day.